Hey everybody, so in this video I'll be building a battery pack for my e-bike, which used to have these 4 sealed lead acid batteries, but of course these things, if you don't maintain them or if you overcharge them, they're going to swell up and go bad. So, and these were brand new, so they got less than a few months worth of, of riding out of them. Anyways, so obviously these guys are going to be out. I'm going to replace it with a lithium battery pack, so that's what I'll be building now. So why would you want to do that? Well, these things are heavy, and they don't have as many recharge cycles. I think they have about, what, 250, 300 recharge cycles. So the amount of money that you're paying, you're not actually getting a lot of use out of them, right? Also, they're just extremely heavy, right? So a lighter battery pack will give you more range, right? So lithium is the option. That's what you want to do, right? So this is the battery box, right? That's what these were in. So if you take this apart, you can see that, it's just an empty shell, and you can probably even hook up the wires and to a battery pack. So I made this one. This is a lithium battery pack, right? It's made out of scrap batteries. This is just a test, and the bike functions fine. There's no issues. Power-wise, it's great. But this was just crap. So I can get rid of these. I'm going to build a good one now. So what do we need to do to build this? Well, you need to first of all make a case for these. Then you need to get the batteries, right? So I have a whole bunch of old laptop battery packs. I'm going to be ripping those apart to source the batteries. Then we're going to test them. Each bank we're going to test. And then once we weld them up, we're going to test the whole case, right? So that's it. So we'll get started with this. This is a 48 volt battery pack. It's 13 in series, and however many in parallel to get you the capacity that you want, right? So I'm hoping that I can get a 13 by 10, right? So that'll give us around a 25 amp hour battery pack, maybe more, never know. And that's it. So we'll start by measuring these up, then we'll CAD a shell, and then print it out in the 3D printer, and then we'll start filling it up with batteries, right? And then I got the welder here, so we got everything we need. Then let's get started.
Okay, so let's start with the CAD software. So I put the dimensions of the box in here. We got some lengths and width measurements. And if you put that all together, then you have your box here, right? Then, using some trial and error, I put the dimensions of the battery, right? So these are 18650 cells. If I stack them on top of each other, I actually run out of room. It doesn't fit. But if you just kind of put a little bit of a gap in them, and then connect them like in an S configuration, right? And then you stack these with a multi repetition. What's it called? Multi-polar? What's it called? I can't remember. This one here. Polar pattern, right? Yeah, there we go. Multi-transform polar pattern. Then you get this, right? So this is the shape that we're going for, right? And that way you can fit in, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be a 13 by 8 battery pack. Which should get us between 20 to 25 amp hours based on our standard 2500 milliamp hour individual 18650 cells. Right? So that should work. Measurements all good. So I'm going to just print a test cube here, and then we'll see how that fits.
All right, this is the small test block that I printed out, and it looks great. It's nice and flexible. So when you fill these up, it fits good. Check it out. There we go. Pretty good. All lined up. Lots of space between the batteries, so we can slip the balance wires in between. We're good. All right, so let's continue. Print out the whole block. Okay, got the full thing printed out. It looks really, really nice, and it fits. Perfect. little bit of room, but once you put all the batteries on it and wrap it up, it's going to be a little bit thicker. But anyways, that fits perfect. So I'm going to get the second one printed out now, and then we'll get started on the batteries. So when you're building a battery pack, you need a whole bunch of batteries. So I've gotten a whole bunch of stuff from auctions, right? So I got a whole bunch of these brand new Ninja battery laptop batteries. I got a whole bunch of bad laptop batteries, but brand name from work. And a whole bunch of other miscellaneous power packs and that type of thing. So I've got a lot of stuff to choose from. So the first batch of batteries that I'm testing are these brand new Ninja battery packs. And these are third party, these are aftermarket. And these are pretty easy to open. You just kind of wrench on these. And you can basically crack the seal. And that's it. So open these up. Just extract the batteries. So if you're lucky, they're in the nominal range. Oh, that one wasn't even connected. Oh, I probably broke it. If you're lucky, they're in the nominal range of 2.8 to 4.2 volts. But oftentimes, these new old stock things are going to be not in that range, so they're going to be dormant. But you can revive dormant batteries as long as they're not like used dormant, right? So it's one thing is if they're new and they slowly kind of just went to sleep, and it's another thing if they're actually been actively used and then they are bad, right? So I've had success bringing dormant batteries back to life, but mixed success. So sometimes it works, sometimes it doesn't, right? So let's see what state these are in. Right, if they're too far gone, 1.7, right? So these are probably asleep. As long as 1.5, 1.9. Okay, so they're not all the same. 2.0. So they're not all the same. Okay, so I don't have the high hopes for these. But anyways, let's bring them back to life and put them on a charge testing machine, and we'll see how they do. Okay, so let's zoom in on one of these dormant batteries, and I'll show you how I revive them. I'm going to say it's the proper way to revive them. This is 1.5. Okay, this is 1.5 here. I have a tab at the end. Perfect. Okay, so just kind of pull out the tabs here. All right. So I have this charger, which is a multi-action charger, but basically I just use this for charging. And then we have the power supply in the top right-hand corner, and then I have these. And then I have this one here. This is a battery capacity tester. So it checks capacity and also checks internal resistance, right? Those are the two metrics on a lithium battery. So let's charge this one, and I'll show you what I mean by a dormant battery. Okay, so if you plug this one in here and in here, okay, it reads 1.5. Put it on a fast charge. So if you click on start, so it complains it cannot be charged, right? So this is the problem. If you've seen those YouTube videos where like, okay, if you have a product and the battery's dead, and you can't charge it, well, what you're gonna need to do is give it a big massive voltage and everything's okay. Well, not really. This battery, I believe, is dormant, which means it's still good, right? So how do you know if a battery is good or if a battery is bad? Well, what you can do is try charging it, right? And then obviously this won't charge because it's too low, right? So this charger says this battery is no good. So what do? Is you give it a little bit of a boost. So see this here, 4.4, doesn't matter, 4.2. So what we're going to do is we're going to attach power to this battery, and when it kind of picks up to minimum voltage, which I think is around 2.5, then this one will say, okay, battery's good, and we'll give it a little charge, right? Basically, we're trying to wake up this battery. Now, how do you know if the battery is good? So watch the voltage on that. So you see how it says 4.4? If I connect positive to this and it doesn't move, that means the battery's bad. But if I connect voltage to this, higher voltage, and this thing has a massive current dip, that means this thing here is sucking up a lot of current and it's waking up. So if you watch it, 4.4, so I'm just going to connect it here manually. Right. So you see how it jumped to 3.5, 3.6, 3.7, 3.8, 3.9. So now I've basically woken it up. If I click charge here, it should start. Take power away. That's it. So now it's charging, right? So what we're going to do is going to give it a little bit of just a couple minutes of charging, and that will be enough to get the battery awake again. And then we can put the battery onto this guy here, and it should charge. So if we take one of these low ones, this I think was 2 point something. 2. This is 2 volts. I don't think this is good, but like I don't think that this guy. I think this one actually will allow an under voltage battery. Anyway, let's put one of these ones here. This is not dormant. This I think is still alive. So let's put this up here. Okay, so we're going to put this on our capacity tester. See what it says. No? No. Okay. Yeah. So even this thing doesn't like it. No. Too low. So this guy here, this is good enough. So we'll stop this one here. Remove it from here. Right, and this one, we should be able to put this on the charger and it should be able to take it. Yep, there you go. So this one thinks it's cool. So put this to NOR test. We'll put it to 700 milliamps of current. That's it. And it will start to perform the test. So basically we'll charge it all the way up to 4.2, then to a complete discharge, and check to see what the, or then it does a discharge, then it does a charge up again. I think it does 2 charges. Anyways, on the way it charges up again, then it checks capacity. So that's the whole process. You need to repeat this 8 times, 13 times. But fortunately, you can get 4 batteries on this. So that's why I like these things. All right, we'll let this go, and I'll do the rest of these the same way, and charge up some batteries. Okay, all of my laptop batteries have been processed. So I'm going to move on to other miscellaneous things. So this is a real Dyson battery, and these are Chinese knockoffs. So all bad. And this is some generic battery pack I got an auction. I got 2 of those. All right, let's take these apart. Chinese one. I wonder what the difference between the Chinese batteries and these. Okay, let's check the voltage on these things. 3.5. 3.5. 3.5. 3.5. 3.5. It's all 3.5. So this was in the recycle bin. Alright. Anyway, we'll put them on the tester, and this is the Dyson one. Okay, yeah, let me open this up and these guys as well. Throw them on the charger. I bet you the Chinese ones are just poor quality. Dyson ones probably just a bad sell. Okay, let's see. So I finished the tests on these Dyson batteries. So this is the original Dyson, and these are the two Chinese. So the tester has determined that the Dyson batteries are 1.8 amps and 40-ish internal resistance. The Chinese ones are actually both better, right? This one is 2 amps and this one is 1.9 amps. So take from that what you will, but the Dyson batteries, this is the original Dyson batteries. Like an original Dyson, yeah, this one here, it's like $100. It's not cheap. And the batteries have less capacity than the Chinese ones, which are at like $30. So looks like the Chinese ones are better than the original. There you go. Anyways, these are all around 2 amps or less, so I can't use these. These are all weaker than all the other ones that I have, which are around 2.3 amps. So these would just throw off the calculations. So I'm not going to use any of these. But anyways, interesting to know. Okay, so using my twin chargers, I was able to complete all the batteries and have a little bit to spare. And when you're done with all of the testing, each battery should have a measurement of a capacitance. So in this case, this battery is 2003 milliamps. So this is a 2 amp battery, and it has 125 milliohm, I think, of internal resistance. So all these are basically around the 2 amp range, right? So these are good for projects, but they're not good for battery packs. So next is the all the power bank batteries. So these ones are a little better. So these ones are in the range of 2.2 amps, right? And I think that's kind of what you want. Somewhere a little higher with this one. So 22 and 125 internal resistance. So, and then these are all of my laptop batteries, right? Which are a little bit better, right? So this one here is 2518, right? And I've marked them, you know, to know which ones they came from. A smaller internal resistance, that one's at 84, right? And some of these are really high. Some of these are up to 2.5 amps, right? So next, the trick is to figure out, okay, well, if I want my battery pack to be balanced, what combination am I going to choose to create the battery pack, right? And so the answer is you need to put a spreadsheet, put all the batteries together, and to figure out which ones you need to put together. So I'll do that in a second. But before I do, I'm going to do one final check of these, right? Because there's another issue that you could potentially have with these, which is internal drain, right? So they're going to be a little bit of, I think they call it parasitic loss on each battery, right? These have been sitting for a while, right? They should all have been charged to 4.2 volts, right? So if it's a little bit less, it's probably not too bad. But if it's excessively less, then that means there's something wrong with the battery. So I'm going to go ahead and go through all these again just to filter out which ones are extremely low. And I'm going to knock those off the list. Crazy. So I've rejected most of the laptop batteries. But it's interesting though that, you know, all of the blue ones here are good. They're still above 4 volts. All of the pink ones are solid. Some of the green ones are okay, and another of the blue batch, different batch, but also blue, are good. And these are all of the ones which are essentially dead, right? So all of these light greens, all of these light blues, and then all of these purples, these are all dead. So I think what they do is, from the factory, they color code the ones that they have confidence in, right? So they'll sell a batch, and they'll know which ones are the bad ones by knowing the colored ones, right? So not all blue ones are bad, but all of these purple ones are bad. Anyways, I don't think there's a universal color across the board, but certainly per manufacturer, they probably know that, batches of batteries they keep together that are known bad, right? Anyways, so that's interesting about Chinese manufacturing practice. So all the batteries have been tested. These are all the remaining good ones. All the blue ones were all chosen. They're all the best ones. These are all from the power banks. These ones from the laptop batteries. All strong, all high capacitance, all still 4 volts, and good for e-bike battery packs. Red ones are also good, but they're lower capacity, so I don't know if the script will need that, but we'll see. All the pink ones were good, and some of the green ones were good. So let's get to this next step, which is selecting the batteries. And for that, we need to turn to the script.
So by script, actually, I mean a computer program that will take all the information that you collected, and then it will select for you which batteries should go in for certain criteria. So I'll explain all that now. So let's first take a look and see how we collected the data, right? So when you are collecting, when you're running all the battery tests, you're going to come up with a capacitance, or sorry, capacity of each battery, and then you're also going to have an internal resistance. And you can make some comments as well. So this is just a spreadsheet, a text-based spreadsheet called a CSV. So you can put some sort of a description of the battery, and then you put the capacity that you've tested, and then you put your value of internal resistance. And then, of course, you can then say either yes, the battery is good, or no, the battery's not good. You can reject the battery. You can say a bad battery. So you can reject all the ones which are no good, and so basically, you're going to end up with a whole bunch of batteries, right? So here we have about 196 batteries, and if they say yes, then they're going to be saved, right? So, and then I wrote a script which essentially goes through the spreadsheet, and then takes a look at all the information and then select. So for example, you don't want to have all the batteries on one bank that are super high, right? Like have like 3 amp range, and then another bank to be less, right? So you need to have it all balanced. So what you want to end up with is a battery pack that's balanced in both the capacity and also the internal resistance, right? So what I do is you sum the capacity, but you average the internal resistance, right? So that all banks then have the same average internal resistance, and then have the same, roughly the same capacity based on what your criteria is. So if we run the script and hold on a second. So if you run the script, then you can specify your parameters, right? So how many that you want in series, how many you want in parallel, that you specify your CSV file, your number of tries, right? So what it does is it creates a battery pack, tests it. If it doesn't fit the criteria, then it rejects it. So it just basically keeps testing until it comes up with a set of batteries which have a capacity variation that is in the 10% of variation. For example, the capacity, 20% capacity percentage change in the IR, and also you can specify I want to have a minimum capacity in the overall bank, and then test it. So so what does that all mean? Well, let's start testing. So for example, we'll run the script. So the first thing it does is it collects all the batteries that have a yes. So there's 107 batteries. We specify 13 in series, 8 in parallel, which gives us a total of 104. So it selects from the given 107, and we're specifying a minimum capacity of 18 amp hours, right? So we're trying to create at least an 18 amp hour pack, right? So every one of these dots is the computer script going through selecting batteries, and then if it keeps going, that means it's rejected it. So it's going to keep going, and then if we're lucky, then it's going to hit a combination that works, right? So we specified 10,000 attempts, and we're just going to basically keep going until we find something. So give it a second and let's see. Let's see. All right, good. So we'll stop the script here and we'll see what the script has come up with. So starting from the top, it attempted 132 times until it found something, right? So it said, okay, bank one, these are the batteries that it wants us to choose, right? So some are from power banks, some are from from the other ones. So this particular bank has a capacity of 19 amps. So this is going to be a 19 amp hour bank, and internal resistance is going to be 97 overall. So, and that's bank one. Bank two, 18.3, 100, 18.3, 109. 18.3, 18.9, 18.2, 18. So this is a just shy of 19 amp hour battery pack. The script has told us which batteries they want us to select, and that's basically one attempt, right? So we can keep running this script and keep running it, and we can tighten up these parameters. We can specify, we want a minimum of 18 and a half instead of 18 and a quarter, and it'll keep chugging away and keep trying to find a combination of batteries that will give us the capacity that we want and the internal resistance that we want, right? So let's keep this script chugging. We'll give it 10,000 iterations. It'll find some, but we'll specify to keep going, and then we'll look through all the results and we'll choose the best bunch of banks that give us the best results, and then we're gonna create the battery based on what the script tells us. So let this run overnight, and then we'll see in the morning how many we got. All right, so it's in the morning, and I ran it. So I ran it for 25,000, and what time did it finish? 425. Probably could run it for 50,000. Anyways, doesn't matter. So let's see. All right, so these are results sorted by capacity, right? So the smallest one, I gave it a minimum of 18 and a half. So in 25,000 attempts, it looks like the best it could do is 18.7. So the IR variation is 0.19. So cap variation 0.06. So let's see if we try to choose, where are we? 0.14, 0.16, 0.17, 0.16, 18.7, 0.06. So if you want to try to capacity variation, IR variation. Okay, let's make that IR variation 18.6. Okay. All right. Let's do this one here. So cap variation is the smallest. IR variation seems to be pretty small. 18.61. Actually, this one's even smaller, 0.14. Okay. Let's choose this one here. So lowest capacity, 18.661. I'll log that text. All right. So we'll do this one here. Lowest capacity. So this is the 2,670th attempt, and so these are the banks. So capacity 18.9, 1904, 18.8, 18.8, and the IR variation is the smallest. So these are all pretty balanced. Okay, let's choose this one here, and that'll give us an 18.6 amp hour battery pack. And so I'll print this out, and then we'll start collecting batteries, and then we'll start welding these things together.
Okay, we're in the garage here. We got our templates ready. We got our cheat sheet ready, and our first bank of batteries. Right. So if you go through all these, just double check that you got the right ones, because if you make a mistake, then you're not only going to screw up this bank, but you're going to screw up another bank. So 24, 62, 117, here we go. All right, so these are all our tested batteries, and so the next step is to get rid of these burrs and chips and things like that. These are all from the previous spot weld, so we need to clean this up. So what I do with this is I make sure that the bottom is flat, because sometimes you gouge it, right? So if it's not flat, then just kind of press down on it, and then grab a Dremel tool, and basically very light pressure until it's flat to the touch. There we go. So as you can see here, I don't know if you can see this, but this is now super flat. Zooming in. Okay, anyways, so this is nice and flat to the touch, and so is that, right? So these are good for spot welds. So finish up the rest of these, do all of these, make sure they're all good, and then we are going to spot weld it, and I'll show you this spot welder next. So this is my welder. Let me just talk quickly about what this welder was, because I've had a couple questions about people asking me about how you build this, etc., etc., etc. So let's begin about spot welders. So this is a basic spot welder. It's got a 1,000 cranking amp battery and a solenoid. So essentially, and a foot pedal. So basically, you step on it and essentially zaps it. So let's first talk about the Chinese. Let's first talk about the idea of how to make a spot welder. So there's a YouTube video where a nice young man from, I think, the UK had a golf cart battery, and then he essentially just rigged it up, and then he had a little hand press or whatever, and he was clicking, 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 and that's where I got the inspiration from this for this design. The problem with that design is that, first of all, that's a low amperage battery, so it might be a little bit forgiving. So if you're a little long with the touch, right, then it doesn't matter, it won't blow holes. But this is 1,000 cranking amps, which is a more common battery, and this will definitely blow holes in the battery if you're not careful. So you need to have computer control to make this work, right? So how I built this one is I use a small little Arduino here, and I have a little potentiometer and a timer. So this is in milliseconds. So as you can see here, it's 13, right? So I can crank it up. So I know exactly how much the duration of the contact is, right? So when you're welding metal, it has to be a minimum of, I think, 13, or else the contact is not enough here. So it has to be a minimum of 13 milliseconds. And luckily, 13 milliseconds is the smallest amount of time you need to weld this nickel plate on top of a battery. When you put nickel on top of nickel, you can crank it up to around 20-ish, right? And that's the setting. Now, as the battery wears, it gets weaker and weaker, and I gotta crank all those numbers. I gotta adjust them up constantly, right? So having computer control is critical. You have to have it, right? And having a little foot pedal here is perfect. So then let's talk about these contacts. So these are copper nails, right? These don't exist anymore. You have to find this somewhere online. I got these from eBay from an old forester company that had a bunch of old copper nails that they would put in trees for some reason. But anyways, copper nails works perfectly. It's hard, and as you can see, I haven't really gotten much wear out of these. This is a simple audio speaker cable. I think it's like 6 ohm or 8 ohm. And essentially this goes to the relay, and this is it. So when these things touch, it creates a spark. And this is a starter solenoid, and the only really thing that you need to do is hook up a flywheel diode, because there's a massive inductor in here and it will explode your Arduino if you don't put a flywheel diode. And the last thing you need to know is power supply. So This thing here is essentially a short circuit across a battery, right? So this, as a 12-volt source, can't be used to power anything because this one essentially has a short, right? And so you need a separate power supply to power just the Arduino, and the Arduino, and it also powers up the relay, actually the FET, which drives the primary inductor on this, right? And then the battery is a second. So essentially the battery is isolated from this power supply, right? So you need to do that because the power source, you need to have a second power source. So all of those Chinese Alibaba, circuit board, spot welders, they don't work. I tried two of them, they don't work. Primarily because you can't use the same power supply. Once you do a dead short, then it screws up the electronics and things short and things explode. So both those Chinese circuit boards exploded with this thing. So they're useless, right? And also you need to have a soldered connection. So this is a copper nail soldered to this, and this one is tightened to that. There is no resistance here, right? Because if you think about it, if you're shorting this battery, you need like 1,000 amps. Right? You can't have a little butt connector or any other type of Mickey Mouse connector, because as soon as you increase the resistance across those connectors, not only will they get extremely hot, even this gets hot, it also drops the voltage, right? There's a potential difference across a resistance source. So those Chinese ones won't generate enough current. Even if you can get it working, they still won't weld the battery properly. This is the only way to do it for a DIY project. Right? Unless you get the industrial machines, which step up the voltage and et cetera, there's a transformer in there. So if you don't want to spend hundreds of dollars on that, this works. And so this is what I'm going to be using. So let's put these on here, put some nickel strips on there, and start welding. All right, we are done welding up one side. So I doubled up the primary lead, right? Because there's lots of current coming off that first bank. And then just put tabs across all the rest of them. And looking good. So that's it. We're going to flip it around. We're going to weld up the other side. And then we're ready for testing. I don't know if you can see it there, but see that spot weld? That just blew through the battery. And it's bubbling up. So that battery, yeah, battery has to be replaced. So I'm going to cut these welds, and that's always the problem because it's finished on the other side. So I have to cut the welds on the bottom, pull that battery out, and replace it. Or else that battery will soon be dead, and it may take down the whole bank and then kill this pack. So, but yeah, there you go. That is dead. This one also kind of blew through as well, but this one did. So I was turning up the battery the time, so 25 milliseconds, but I guess it was just a little bit too aggressive. I should have kept it a little bit lower. The rest of them were good welds, but too bad. Okay, well, let's replace it. All right, we are done. So that little repair job turned out good. Everything's all welded in and looks good. So let's check the voltages. Wow. How about this way? And we'll check the voltages. So if everything went right, we should all be clearly into the 4s. If anything went wrong, then we will not be in the 4s. All right, so let's see. So this is number 1. Good. So I am going to, actually that's all pretty good. I'll just record what they are, and then we'll put them on a test bench and we'll do an actual drain test on this next. So let's do that, and I'll show you the tool that I built to do the current draw test. All right, this is my test bench. So this is what I built to test actual load on lithium battery packs. So as you can see here, there's a bunch of car headlights. So what this is a strings of lights that are set in series that take a massive current draw, right? And since they're light bulbs, essentially they're resistive loads. So this is a pure DC load tester. So basically how it works is there's a string of lights, and then there's a, it used to be a relay, but I've upgraded to a large either MOSFET or IGBT, I can't remember. So basically I can enable all these, and then there's a current sensor here. So I can check what the current is, right? And also I can use the Arduino, which is here, to check the voltage values, right? So what I do is you hook up your lithium battery, you set what lights that you want enabled, you check to see how much current they draw, and then you hit test, and essentially it will take the voltage to some value that you've predetermined. So basically what I do is you charge up the battery, you set the voltage to be at, per cell, let's say 3 volts, and then if it's a 13 series, it's 13 times 3. So I don't know if you can see it, but it's right now the current voltage is 55.4, and then my target voltage is 35 volts. So once I hit the light enable, this thing has a timer. I enable the lights, and it draws that much current for that much time. So based on that, I can tell what the capacity is of the battery pack. So this one here is another battery pack I have. It's 48 volts. This is a 20 amp hour battery. So what that means is that I should be able to draw on this thing 20 amps for 1 hour. And I can do that using these resistive loads, right? So right now it's hooked up. I think just this one is enabled. So this is probably too blinding, but even it's too blinding for me. So if I fire this up here, this bank is enabled, and it was drawing 11.6 amps. So essentially, you can draw 11.6 amps for 1 hour, gives you an 11 amp battery pack. So if you're 20 amp battery pack, this battery pack should go for 2 hours under this load, and it should be fine. There shouldn't be any issues with that, right? So that will give you the true test of this battery pack, right? And that's it. And also you can measure each bank, and you can check to see if there's too much drop per bank. And you can determine, because there's a manufacturer spec for that too, determine if that the health of the battery pack as well. So I'm going to hook up the battery pack I got now, and then we're going to do a load test. I don't have the BMS hooked up to it yet, so I do need to keep checking the banks to make sure they're okay. But after, I'm going to check it after a minute, then I'm going to check it after half an hour, then I'm going to check it after an hour, and we're going to check to see what the health of the banks are. So I'll be able to tell from that, and also I can test the capacity, and it should work out if all the calculations are correct. Alrighty, let's give it a shot. Okay, let's begin the test. We got the battery hooked up. So we're going to test it in various times, and then we're just going to record the drop off to see if we can monitor if any bank is bad, and also generally the condition and the health and all that, right? So I think this one is at 11.5. 11.5. Okay, so this is going to be volt to start. So this is at 11.5 amps. And okay, so let's start the test. We'll start measuring. I got the initial voltages down. Alrighty. So 11.5 should run for it's okay, 4.0. So 05, 10, 4.5, 4.10, 4.6, 2, 7, 6, 2, 7, 3, 5, 6, 6, 3, 5, 4. Okay, so that's the initial one. I'll check the drop, and then we'll check probably after half an hour, and then after an hour, and then we'll see at the end, right? So if all the banks are dropping gradually, which is what you want, then this should go right to the end. So this is unprotected. There's no BMS on here right now, right? But if everything is working, then this should be fine without this. But anyways, I'll keep an eye on it, because you don't want any bank to go below 2 volts, 2.8 volts, right? And if it does go 2.8 volts, that means there's something wrong, and we have to take this whole thing apart. Not the whole thing, but the bank apart. But anyways, let's hope everything's okay, and we'll see what we get.
All right, so the test is finished, and this is a summary of the results. So I stopped it at 2 hours, and the average voltage was 3.4. So this is a solid 20 amp hour battery pack, right? So it did 10 amps, actually over 10 amps for 2 hours. So that means 20 amps, 20 amp hours plus. And 2 hours is a duration. And then I recorded the banks as it went. So after 2 minutes, after 47 minutes, after an hour and 21 minutes, and after 2 hours. So if you take a look at the graph, you can see that that the banks themselves are very tight, and there is not any wild readings here. So this battery bank is in great condition. Everything is working properly, and the drops are very tight, right? So this is great. I'm happy with this battery pack. So I'm going to weld down the BMS, and then we'll do a full charge up, and then we're going to do a basic test till empty, and then we'll see how that goes. And then basically the battery's ready.
Okay, so let's test to see how we did. So from battery negative to battery positive, 46.1, and from BMS negative, battery positive, 46.1. Good. Same thing with charging too. Good. All right, let's wrap this up. All right, I charged this thing last night, and actually I charged it yesterday, and I stopped it last night. So it went well. The battery, the BMS is in and all wired in. So I left it. I'm hoping that it would balance overnight. So this one's 419, 420, 418. This one was the higher one. 420. Yeah, this was like 420, 424. So overnight, this thing has slowly tried to balance up the banks. And that's amazing. So we are good. In fact, I could probably even turn this on again and probably go off again. No? Oh, probably because it's still in the balancing mode. So once it's done a full balance, then it would pop in again, or you just use it again. Anyways, so these things are basically balanced within whatever. Yeah, 419, 416. Yeah, so probably which one? This one's 420, 418, 420. Yeah, 420. There's probably that's it's stopping the charge because the banks are in the balancing phase. Anyways, all good. This is great. So let's now wrap this up with plastic with tape, and we'll make sure it fits inside the box, and then I think we're done. All right, we're ready to put this in here. Now the charge cable actually goes like this. Charge cable needs to go somehow into this here. I think I'll just drill a hole and let's see if I can feed it through there. Something like that. Now this thing likes it. Ooh, maximum. Ooh. All right, so I'm mostly interested to see how much its battery dips. Because usually when you crank it, if it's a bad battery, it dips like a lot. I don't see any dipping now, but there's no load on it. Let's go for a boot outside and see how it goes. Alright, feels good. Alright, let's give it full throttle and see how much the battery dips. Okay, not bad. Cool.